Misleading statistics. Objective of this lesson to recognize when statistics are misleading. Let's take a look at this example. Mr. Snyder's sociology class was studying birth rates in the United States for a project on the history of birth rates from 1960 to 1990. Maria and Jennifer made two graphs as shown below. And if you look at those two graphs, study them for a few seconds. And let's answer the questions that follow. Do both graphs show the same information? Okay. Which graph suggests a baby boom from 1975 to 1990? When you talk about a baby boom, it simply means a dramatic increase in birth rate from 1975 to 1990. Which graph suggests a fairly steady birth rate? Okay, so these three questions we can answer by just looking at those two graphs. The first question, do both graphs show the same information? Okay. Oh, there's one last question. What is the same? What is the difference between the two graphs? Okay, the first question, do both graphs show the same information? The answer, of course, is yes, they do. Okay. Both graphs show the same information. Okay. Which graph suggests a baby boom from 1975 to 1990? And if you look at those two graphs, graph number one, this graph right here will show a baby boom because look at from 1970 to 1990, there is a dramatic change in the slope of that line. And in the graph at the right, the slope is not that great from 1975 to 1990. Which graph suggests a fairly steady rate? We answered that question. This graph, because of that relatively small slope, okay, compared to the slope of the graph on the left. Okay, and the last question, what is the same and what is different about the two graphs? If you notice, okay, this graph on the left does not start at 0. This graph on the right does. Okay, what else do you notice? The intervals of this graph is by 0.2, small intervals, okay, on the horizontal axis, sorry, on the vertical axis, and the intervals here are by 1, okay, and at the same time, this graph starts at 0. Okay, we talked about that. And look at the years on the horizontal axis and the graph on the right. Okay, 1965, 70, 75. Okay, smaller intervals, larger intervals on the left graph. Okay, so by just looking at those two graphs, we know right away, okay, which graph can be misleading. The data used in the graphs above are the same. We answered that. However, different scales were used to make the data appear to support a particular point of view. The soaring graph at the left is a result of an extended vertical axis and a shortened horizontal axis. Okay, a small break in the vertical axis is used to show that the axis is not to scale between 0 and 27, or sorry, 0 and 2.7. However, it is visually misleading when compared to the complete scale, the graph at the right. So what is it saying? The graph on the left does not have a complete scale because it does not have start with 0 compared to the complete scale, the graph on the right. What it's saying is this: if you are going to do that, then you need to basically, if you're going to start with 2.5, then you need to create a 0 down here probably and create what we call a break all the way to 2.5. Okay, because if because of the fact that they did not create a break, this graph now is your misleading graph, and this is your more accurate graph right here. Okay, so what do we notice? Let's take a look at example number 2. The graphs at the right display data about movie attendance. Is the top graph misleading? Explain. Okay, so we know that the top graph is misleading simply because there are no labels, there is no title, okay, and it does not include 0. So there should be a label here. There should be first and foremost a title. Okay, title, and there should be a label on your horizontal and vertical axes. And at the same time, this should start at 0. If it does not start at 0, it should have a break to indicate that it did not start at 0. Okay, and look at the bottom graph. You know that there is a label, there is a title, there's a label for the x and y axis, starts with 0, intervals are relatively the same, so this graph is not misleading. The graph is not misleading, all the necessary information is present, the scales are labeled, the distance between the units on each axis is uniform, and the vertical axis includes 0. So this graph is not misleading whatsoever. Okay? Take a look at the next example. But before we do that, let's go back to our measures of central tendency. Okay, if we use the measures of central tendency inappropriately, then it can be misleading. Again, measures of central tendency are mean, median, and mode. Okay, why are they called measures of central tendency? Simply because of these reasons. Median is the center, literally, since it is the middle value that divides the data in half. So when you talk about median, it divides the data set in half. Okay, mean can be considered the center of the data because since it balances out the highs with the lows. So when you remember what the mean is, you add up all the pieces of data and you divide it by the number of pieces of data. Okay, it balances out the highs and the lows. That's why it's also considered to be a center. And finally, mode is considered to be the center of the data since it is the value that occurs the most. And that's the reason why they're called measures of central tendency. But there's a problem. Sometimes we can misuse mean, median, mode for our own purposes to mean some other stuff. When can they be misleading? Okay. The mean has one disadvantage. It is particularly susceptible to the influence of outliers. Okay, these are values that are unusual compared to the rest of the data set by being especially small or large in numerical value. Let's take, for example, the gold medal example a few lessons back. If you notice in 1980, okay, if you still remember, 1980, okay, the United States has 0 gold medals. In 1984, the United States had 83 gold medals, but the rest of the values of the rest of the data around 35, 38, 41, 42. Okay, so if you notice, these are outliers, and if you get the mean, okay, of this set of data, okay, it will not be representative because of these two outliers, and that's when the mean becomes misleading if you use mean to represent this set of data. Okay, the mode can also be a problem. Let's take a look at how it can be a problem. One of the problems with the mode is that it is not unique, so it leaves us with problems when we have 2 or more values that share the highest frequency, meaning to say, when you talk about the mode, okay, if you have more than one mode, okay, it cannot be representative of the set of data. Okay, another problem with the mode is that it will not provide us with a very good measure of central tendency, when the most common mark is far away from the rest of the data in the data set. What does that mean? If the mode is close to the lowest value or the greatest value, okay, it can be misleading. So when the mode is close to the least value or the greatest value, the mode can be misleading, or if there is more than one mode. Lastly, median. When is median misleading? Let's find out. A little bit of a long example. This is more than you need to know, but good information nonetheless. Okay. So when you talk about median, this is useful when the samples are normally distributed. What does that mean, normally distributed? That is when the median is the most common value and there tend to be fewer values as you move away from the median in either direction. Okay, so when you talk about median, you have a normal distribution of values. The median also reduces the effects of outlying values. So basically, when you talk about the example that we had with the Olympic gold medals, the median will reduce the effect of the 0 gold medals and the 83 gold medals. Okay, let's take a look at these examples. Suppose you want to know the average height of students in second grade class. You want to find the median. Why? Because if most are, say, between 4 and 5 feet tall, the median will be a reasonable estimate, and it won't be affected by the 7-foot basketball player who was held back 4 times in second grade. Okay, that's a bit of an exaggeration, but if you have a let's say a 7-foot basketball player, okay, that would skew your data, since her actual height isn't taken into account. The only fact that she's taller than average. So the median would be a good way to find this. On the other hand, suppose you found an amazing retirement fund that doubles your money every year, and you invest $100 for 10 years. At the end of each year, you'll have, let's say, these amounts: 100 for the first year, 200, 400, 800, all the way to 102,400. Okay, now look how this becomes misleading. If you want to know how much money you've had average, and you calculate the mean, okay, by adding the numbers, dividing it, you'll get 18,609. Okay, but then again, if you find the median, it's only 3,200, which is very different, because the amount of money increases faster as time progresses. And this is when your median will be very misleading if you have this type of data. Okay, so mean would be the best way to do that. Okay, and this is just a table. Okay, not turn that. Okay, this is just a table on when to use the 3 sets. These are good examples when you use the 3 measures of central tendency. Use the mode, let's say, when you're talking about the jersey number most worn by players of a franchise. Okay, you want to use the mode when you want to find the typical shoe size of a basketball player. You want to use the mode when you want to find responses to multiple choice question. Okay, and the typical jersey size for players as well. Okay, when you use the median, and you want to find the cost of the cars, cost of the college tuition, and cost of houses in a certain state. And when you use the mean, code L1 will be average height of players, of boys and girls in a certain age, average score on a given test, average monthly electrical bill for a household. That was a mouthful. Okay, so these are good examples when to use the mode, when to use the median, and when to use the mean. Okay, let's take a look at this example, and let's wrap this up. After a semester exam, Mr. Myers displayed the results to the class. The scores are shown in the stem and leaf plot. Mr. Myers told the principal that the average grade in the exam was 77. Ryan told his parents that the average class grade was 93. Tai told her grandmother the average class was average class, or the class average was 80. How can all people think they are all correct? Well, they used different measures of central tendency. Each person used a different measure. Okay, Mr. Myers used the mean, Tai used the median, and Ryan used the mode. Okay, the problem with Ryan is that he used the mode. It is also misleading because 93 is also the highest score in the exam. So if you look at the mode, it's 93. Okay, it becomes misleading now because it is the highest score. It is the greatest value, and we'll discuss that. Okay, and that's when you find out when measures of central tendency become misleading. Google Forms, type a summary of what you've learned and a question you might want to ask in class. Thank you.